All right, so if you drop an object and it falls, and then it hits another surface, and then it slows down, and let's say it stops. Imagine a rock falling into water. You're going to have two different periods of motion here that's happening. Very similar. This is like the opposite of the rocket scenario, but you're going to have an acceleration here. You're going to have a time here. You're going to have a distance here. You're going to have a velocity initial here. You're going to have a velocity final here. That is for these scenarios. You're also going to have an acceleration down here, a time down here, a distance down here, a velocity initial down here, and a velocity final down here. That's for these scenarios. One thing to note and to remember is the velocity final here is equal to the velocity initial down here. The acceleration here would be negative 9.8 due to gravity. You have to have the velocity initial here is 0. For this scenario, you need one more piece of information. You need something given to you. For our egg drop project, I'm going to give you distance. To start out your number calculations, you can assume 10, but I'm going to give you a distance. It'll be whatever we determine the balcony to be, but you can pretend it's 10 to start with just so you can start practicing your numbers. You have to have a third thing, which would be distance, because you have acceleration, velocity initial, distance, and you can solve for these other two. I'm sorry, you can solve for this one and then this one. Down here, you're again going to need to know distance. That's something you'll measure on your device. You'll have velocity initial because you'll have it from up here, and then you'll need to assume that velocity final is going to equal 0. That'll be the 3, and you can solve for these. You'll use these because in the equation, force times time equals mass times velocity. You'll use this velocity here, which is your velocity final and initial, and you'll use the time you get here for this time. You'll measure the mass, and you'll solve for the force.